Okay, guys, today we're going to be working on simplifying expressions. We are in the Course 2 book. And this starts on page 62 where I'm starting. I'm actually skipping chapter 1 and we're going to go to the second lesson in chapter 2 because I think you know the first lesson. And you'll probably even know a little bit of this that we're going to work on today. But this is the first page of that second lesson in chapter 2. And today we're going to be talking about a couple of things in particular. And the first one is going to be like terms. I think I've used this before. And we're going to be talking about coefficients. This is another word I think I've used, but we're going to talk about in a little bit more detail, and I'll probably flip back to this page as I need to. Okay, so before I actually talk about like terms, I want to make sure that you understand what terms are, okay? So I'm going to get rid of this here. Terms of an expression are the things that are getting added or subtracted. So I've given you this as an expression. This is an expression. This is an expression, okay? We're looking at these expressions, and this actually has two terms in it, okay? This expression has two terms. One of the terms is x, and the other term is 5. I want you to notice that there's a plus sign here, and the plus sign separates this up into two terms. When I go to this one, I've got another plus sign. This is also separating it up into two terms. One of the terms is 3x, and the other term is xy. So this is also two terms. One of those terms is 3 times x, and the other term is y times z. And it's that plus sign that shows the two terms. This one has three terms. Okay, I have a 4, I have a 5y, and I have an x, because we've got a subtraction sign here, and we've got an addition sign here, and so this separates this up into three terms. This is a 4, and actually this isn't a 5y, it's a negative 5y, because I can make that plus a negative. So we're looking at those are the different terms. And so what we're going to be doing is we're going to be combining the like terms. So I've given you a whole bunch of terms on this page, and we're going to group the like terms with each other. Here's m all by itself. It's just m. It doesn't have an n attached to it. It doesn't have a number, but actually it kind of does have a number, because m by itself is the same thing as 1m. So you can actually understand that there's a 1 there with that. This is not like that term. It doesn't have an m. And this one down here has an m, but it's an m to the second power, just like 4. 4 is different from 4 to the second power. 4 is just 4. 4 to the second power is 16. So they're not really like each other, even though they have that same base of 4. So I'm looking for like terms. Like terms, like terms. Oh, here's one. I have a 1m and a 3m. Do you see any other ones? Yep. There's a 14m. Are there any other ones? I think that might be it. Okay, let's try this one. 8n squared. That's to the second power, but it's not an n. I need an n. I'm looking. Oh, there we go. 12n squared. And here's another one. 2n squared. Those are all like terms. I can actually add those together. Here's 1n. Here's 3 more m's. And here's 14 m's. And so that ends up being 18 m's if we were to add them all together. You see that? We can actually add them all together because we're just talking about numbers of m's. Okay. We've got 8m squared. Oh, look, the 4m squared and the 5m squared are right under it. And look, the 2m squared can go with that. We've got 9mn and a 20mn. Is this one like that one? think about it for a second. Can't we use the commutative property to move the m and the n and switch their places? Yes, we can. So you should be able to see that this is just like that. And because I can change its form into another term. So now I could actually add these pieces together by looking at the coefficient. The coefficient is the number right in front of the variable. And I can essentially add all these up by just adding the coefficients. 8n squareds, that would be like this. N squared plus n squared plus n squared plus n squared. That's 4. That's 5. There's 6. There's 7. There's 8. And I could add 12 more of those and then 2 more of those. That would take me a really long time. So if I can understand that really all I have to do is add the coefficients of the like terms, then I can see that I can combine them pretty easily, okay? So really all I have to do to add these together would be to add up the 8 and the 12 to be 20 plus another 2. So that would be 22 n squareds if we were to put all of those together, okay? And we could do that for each one of these. That just kind of gives you an idea of like terms and how we combine them. So I explained here, 8 is the coefficient, 5 is the coefficient, 4 is the coefficient, and you might like to look at this one and say, oh, there's no coefficient, but that's not true. If there's a number by itself, then it's understood that there's a 1 in front of it, so 1 would be the coefficient. So if we're going to separate these, I want you to notice that this is 4 terms. We've got, I'm going to highlight them. I've got 5x, I've got a 9, I've got a 2x, and I've got a -4. Remember, this is actually a -4 because this is like a plus a -4. Now, when I make it all into addition, I can move these terms around and put them in any order I want to. So I might move the 2x over by the 5x and put the 9 with the -4. Then that way I can actually add 5x and 2x together to get 7x, and I can add 9 and -4 to get 5. And that would be my simplified expression. I can't get it any simpler than that. Okay, in this one, how many terms do we have? We have 4 terms. If it helps you to make these subtraction signs into plus and negative, and then whenever you see your addition signs, then you can see 1, 2, 3, 4 terms, okay? Now we're going to combine the like terms by moving some things around. I'm actually going to move the k, or leave the k, and move the -9k next to it. And then I've got the -2 and the 7 together. One thing I want you to notice is I can't move the numbers around until I make it into addition, because subtraction is not commutative, only addition is. Okay, now we're going to add k plus -9k. Remember, this is like a 1k here. So this would be -8k plus, now I'm going to add -2, that wasn't a good color, -2 plus 7, and that would give me 5. And so -8k plus 5 is the simplified expression. Now this one, order of operations would tell us we're supposed to do what's in parentheses first, but because we can't add 6s plus 1, then what we can do is we can actually get rid of the parentheses by doing something called, or using a property called the distributive property. And basically what we're saying is, since this 2 is in front of the parentheses, that if I distribute this to each of the things in the parentheses, then I can actually get rid of the parentheses altogether and combine like terms. Something really tricky here, though. This is actually a -2 that's going to get distributed. Okay, so I'm going to have my 8 plus, Then I'm going to do negative 2 times 6s, and I'm going to do negative 2 times 1. So I've got 8 plus, now I'm going to multiply these two together, negative 8s, no, it's not negative 8, sorry, negative 12s plus negative 2, and then I can combine this with this using my knowledge of like terms. So I'm going to move those next to each other. And if you can do this without moving the terms, if you can just mentally see how to move them, that will work just fine. Here, we want to get rid of the parentheses by distributing the 6 to each of the things inside the parentheses. Then we can get rid of the parentheses. So we're going to have 6 times 2x plus 6 times 3, and then I've got my minus 4. So I'm going to do this part first, 12x, and now I'm going to do this part, and now I've got this, so I can add these two together. Add those two together, and I've got 12x plus 14. That is my simplified expression. Here, I'm going to distribute the 1/2 to each of the things inside. And if you want to make this plus a negative, I think it's a good idea. 1/2 times 2 is 1. Plus 1/2 times negative 8v would be negative 4v. And then I still have my plus 5. I can do the 1 plus 5 and combine those and get 6 plus a negative 4v, and that would be simplified. Okay, here I'm going to make this into plus a negative 4, and then I'm going to distribute so that I can get rid of the parentheses. So I'm going to have 9 plus negative 4 times 3z plus negative 4 times 2. So I've got 9 plus negative 12z plus negative 8. Now I'm going to move these things together because I should see that I can combine negative 8 and 9. So I'm going to move those next to each other. I can do that because addition is commutative, and I get 1 plus negative 12z. Okay, give it a try.